Hello Year 5 and welcome to Week 5 Wednesday's maths session. We're going to do a little bit more work to begin with on finding fractions of amounts, but we're going to look at finding fractions of amounts in a slightly different way. So I'd like you to have a little look at the question on the board. This first question that we're looking at over here, where it says 3/5 of something is 18. Now this time we actually don't know what the whole amount is. That's actually what we are trying to find out. But we have been given parts. So what we're going to think about to begin with is how many parts should there be to this whole? We're looking at our fraction. There should be 5 parts. We're going to break our bar into 5. And we're going to think about how many parts do we know about? Well, what we actually know is that 3 of our fifths is equal to 18. So if 3/5 are equal to 18, is there a way of working out what 1/5 must be? Have a little think. You might want to pause the video. So when we're talking about breaking 18 into 3 equal parts, we're actually looking at division. So we're going to do 18 divided by 3. And 18 divided by 3 is 6, because 3 times 6 is 18. So we now actually know that 1/5 is worth 6. So if all of these fifths are worth 6, how much does that make altogether? 6 lots of 5 makes 30. 30 divided by 5 is 6. So our question mark, our whole, is equal to 30. And this is where a bar model really helps with this. You might start to realise, what did I calculate? Well, I actually divided between the 3 parts of the numerator, and then what I did was multiplied by the parts of the denominator to get my 30. But the bar model at the moment, this is quite a tricky concept to get our heads around. The bar model really helps us to understand what's going on. So the same thing here, 2/8 of something is 16. So what we're actually missing then, once again, is we're missing our whole. That's what we're trying to work out. What has our whole been broken into? Yeah, our whole has been broken into 8 parts. So we'll make our 8 parts here. And how many of those parts do we know about? We know about 2 of them, and we know that 2 of them are equal to 16. So if 2 of them are equal to 16, how can we find what one of those 8s is worth? That's right, we're going to divide our 16 between our 2 8s, which actually gives us 8. So if this 8 here is worth 8, then every other one is also worth 8. And how many 8 parts have we got here? 8. So we're looking at 8 multiplied by 8 gives us a total of 64. So what we've actually done is we've done the opposite to what we were doing before. We've divided by the numerator this time first, and then we've multiplied by the denominator to find the whole. Now let's have a look at this one. So 1/4 of something is equal to 4. So we're unsure of what our whole is at the moment, but we know that one of them, 1/4, is equal to 4. Therefore then, obviously if our 1/4 is equal to 4, then all the other quarters are also equal to 4. So in order to find the whole, we need to do 4 multiplied by 4, which gives us a total of 16. So our whole is equal to 16. Let's have a look at this one down here. This time, again, we don't know at the moment what the whole is, but we are looking at 3/4, and we know that 3/4 is equal to 24. So if 3/4 is equal to 24, we want to divide that 24 between those 3/4, which gives us 8. Now we can see that 1/4 is worth 8. This last quarter must also be worth 8. So 4 lots of 8 equal to 32. So our answer is 32. Now these are a little bit trickier today, so have a little look and choose your level of challenge. It might be that more of you decide you're actually going to begin in this column today. If you know what a fifth of a number is, can you use your bar model, a bar of 5, to then work out what the whole is? If you feel more confident, you can try the orange challenge, or there's obviously the red challenge there for you as well. So have a little go, pause the video now, and see if you can work out what the wholes are for these calculations. And here are our answers for you. Don't worry if you found this quite tricky today. This is the harder kind of finding fractions of amounts, or finding the whole of a fraction given. Now on to our main session today. Can I solve problems using negative numbers in a context? So you're going to use this knowledge that you've gathered around calculating with negative numbers, whether that's addition or subtraction, and also finding the difference, in order to help you solve this problem today, which is all going to be based on The Lion, the Witch and the Wardrobe, or Narnia possibly, if you have heard of that film before, or the stories. So to be successful today, you're going to need those number bonds to help you again. You're going to need to use knowledge of subtraction and addition, and you're going to need to use a number line to help you to calculate. So as I said before, you may have read the story, you may have heard of the story of Narnia, The Lion, the Witch and the Wardrobe, and this is what our problem is going to be based on today. Now what I will say is Narnia had a spell cast on it by the witch, and she made it so that it was always winter and never spring or summer. So as you can imagine, the temperatures in Narnia are often rather chilly. So, just something I'd like you to have a little look at then. If Mr. Tumnus checks the weather on his phone, what could he tell from the screen? So maybe pause your video now and have a little look at this. Okay, so probably a weather forecast you've seen many times before, and we can actually see that obviously this is showing the temperature of Narnia, and it's showing that today it's mostly sunny, but clearly the temperature is -10, which is rather chilly. What we can see though, if we look at the temperature now, and you can see the timings along the top here, we get to midday, you can actually see that it is getting a little bit warmer as the day goes on. And if we look at all the sort of long range forecast here, can we see which day is actually going to be the warmest? It's going to be Wednesday here, isn't it? 5 degrees. But actually, on the Saturday, the temperature could get as cold as -3. So there's lots of information we can gather about the weather warming up, which day it's the warmest, which day it's the coldest. And generally, we can see that Narnia is quite a chilly place. Now, if we compare that then to the temperature of Narnia and the temperature of Eastleigh, we've obviously got -10 here and 9 degrees. So, if we did compare, if we looked at finding the difference between the two temperatures, we've got Narnia here on -10 and we've got Eastleigh on 9. So I wonder, what is the difference between those two temperatures? And you might want to pause the video now to have a little go at this. So we can see to get from -10 to 0, we've obviously got 10. And to go from 0 to 9, we've got 9. So 10 and 9 is 19. And what we'd actually say is there's a difference of 19 degrees Celsius. And you can see here this degree sign in our weather forecast to show that's how we measure temperature. So we had a look at finding the difference here. And like I said before, we started on -10 and we needed to find the difference between -10 and 9, and the answer was 19 degrees Celsius. Let's have a look at another one. What would be the most efficient method of comparing these temperatures? Well, actually it's using that blank number line again, isn't it? So we've got -18 and we want to get to 11 to find the difference between the two. So we use our 0 as our marker to get to, and then 0 to 11, we've got 11. So altogether 18 and 11 equals 29 degrees. So the difference between these two temperatures in Narnia, goodness me, it must have been a cold night, it looks like here. The difference in these two temperatures then is 29 degrees. Another type of question you might have today will include calculating like we did on Monday. So let's have a look at this question. What if the temperature in Narnia rose by 14 degrees? I'm just going to stop there to look at this word rose. And what I want you to think about is what this means is getting warmer. So what we're actually looking at there then is adding. If it had said dropped or got colder, we would have been looking then at subtracting. So we're looking at the temperature in Narnia being minus 10 degrees and it's rising by 14 degrees. What would the new temperature be? So we need to add, we need to increase the temperature, we need it to go up to get warmer by 14 degrees. Well, I'm going to go back to that method I found useful on Monday. So I'm going to add on 10 to start with, and if I think about my 14, if I've added on 10 already to get me to 0, I'm going to need to add on another 4 to have altogether added on 14 degrees. And so the answer, the new temperature, would be 4 degrees Celsius, much warmer than minus 10. That would be the new temperature. And finally, one last one. What if the temperature dropped? And that's where we're talking about it getting colder. We're looking then there at subtracting. If it's getting colder, if it's dropping, we're subtracting. So in Eastleigh the temperature was 9, and this time we're going to get the temperature to drop by 14 degrees, so we're subtracting. So first things first then, let's get back to 0 as we like to. We've subtracted 9, so if I think about my 14 degrees, what can I partition it into? 9 and 5, that makes 14. So take off 5, leaves me with minus 5. So if the temperature dropped, it would be a very chilly minus 5. So your first page of your work today gives you a letter, and I'm going to read that letter to you now. Dear student, I've been informed you may be able to help me in my time of need. The White Witch has stolen all the temperatures in Narnia, and I need you to help me get them back. I am afraid that I cannot help you other than providing a clue I found in an old book. And it gives you 2 different methods there, so you can see that those methods we've just gone through together. My final piece of advice is the questions are not in order. You will need to find your starting point and use what you know to help you find the next one. So there's a little bit of clue gathering today. You're going to have a set of instructions, a set of clues for you to try and work out what the different temperatures are around the world of Narnia. Okay, and sometimes it will be finding the right question first that kind of unlocks the answers to the others. If you find any of this tricky, do get in touch with your teacher and they might be able to give you a starting point to begin from. But if you can use those methods of finding the difference and adding and subtracting with negative numbers that we've been using so far this week, that's going to really help you. We hope you enjoy this challenge today and we look forward to seeing how you get on. Thank you.